Sailing is a dance with nature, a harmonious yet sometimes challenging interaction between humanity and the elements. As sailors, we entrust our lives to the sea, guiding our vessels across vast expanses of water where weather patterns can either be our greatest ally or our most formidable adversary. Understanding these patterns isn't just a matter of convenience, it's a vital skill that can mean the difference between a smooth voyage and a perilous journey. This guide aims to delve deeply into the intricacies of weather patterns, offering sailors both seasoned and novice a comprehensive understanding of the elements. From reading the sky to interpreting forecasts, from the calm of a clear day to the fury of a storm, we'll explore how mastering the elements can enhance your sailing experience and, more importantly, keep you safe on the water. The importance of weather awareness in sailing. Weather awareness is paramount in sailing. Unlike driving a car or riding a bicycle, where you're relatively sheltered from the environment, sailing places you at the mercy of nature's whims. The wind, waves, and weather systems are not just background details. They are the forces that propel your boat, determine your course, and influence your safety. Understanding weather patterns allows you to make informed decisions, whether you're planning a day trip along the coast or embarking on a transoceanic voyage. It helps you anticipate changes, avoid hazards, and make the most of favorable conditions. In essence, weather awareness is the foundation of successful and enjoyable sailing. The basics: understanding weather systems to navigate the seas effectively. It's essential to grasp the fundamentals of weather systems. These are the large-scale patterns in the atmosphere that dictate the wind, temperature, and precipitation you experience on the water. High and low pressure systems. At the heart of weather patterns are high and low pressure systems. These are areas of the atmosphere where the pressure of the air is either higher or lower than the surrounding areas. High pressure systems, often associated with calm, clear weather, high-pressure systems are characterized by descending air that suppresses cloud formation. These systems can create stable conditions, ideal for leisurely sailing, but they may also result in light winds, which can be challenging for those relying on wind power alone. Low-pressure systems. In contrast, low-pressure systems involve rising air that leads to cloud formation and precipitation. These systems are typically associated with more dynamic weather, including strong winds, storms, and changing conditions. Understanding the behavior of low-pressure systems is crucial for avoiding dangerous weather at sea. Fronts. The boundaries of change. Weather fronts are the boundaries between two air masses with different temperatures and humidity levels. They are often the sites of significant weather changes, making them critical to monitor. Cold fronts. When a cold air mass moves into an area of warmer air, it forces the warm air to rise quickly, often leading to thunderstorms, heavy rain, and a sudden drop in temperature. Cold fronts typically bring a wind shift from southwest to northwest in the northern hemisphere, which can be both a challenge and an opportunity for sailors. Warm fronts. A warm front occurs when a warm air mass slides over a cooler air mass, gradually displacing it. Warm fronts usually bring gradual weather changes, including steady rain and an increase in temperature. Winds ahead of a warm front generally come from the east or southeast, shifting to the south or southwest once the front passes. Occluded fronts. These occur when a cold front catches up to a warm front, lifting the warm air off the ground. Occluded fronts can bring complex weather patterns, often leading to prolonged periods of precipitation and variable winds. Stationary fronts. As the name suggests, stationary fronts are fronts that have stopped moving. They can lead to prolonged periods of steady rain or storms, depending on the surrounding weather systems. For sailors, encountering a stationary front requires careful planning, as the weather can remain unsettled for days. Wind. The lifeblood of sailing. Wind is the driving force behind sailing, and understanding its patterns is crucial for setting your course and maintaining control of your vessel. Wind patterns are influenced by global circulation, regional weather systems, and local factors such as land masses and water temperatures. Global wind patterns. The Earth's rotation and the uneven heating of its surface create large-scale wind patterns known as the global circulation. These patterns include trade winds, found in the tropics. Trade winds blow consistently from the east and are among the most reliable winds for sailing. They are ideal for long voyages, especially across the Atlantic and Pacific Oceans, where they have powered countless journeys throughout history. Westerlies. Located in the mid-latitudes, westerlies blow from the west and are more variable than trade winds. They are often stronger and can be more challenging to navigate, but they are essential for routes across the North Atlantic and North Pacific. Polar easterlies. These winds blow from the east in the polar regions and are generally cold and strong. They are less relevant for most sailors, but those venturing into high latitudes need to be aware of their potential impact. Regional wind patterns. While global winds provide the broad strokes, regional wind patterns add nuance to a sailor's understanding of the weather. These include monsoons, seasonal wind patterns, primarily affecting the Indian Ocean and Southeast Asia. Monsoons bring significant changes in wind direction and strength, along with heavy rainfall. Understanding the timing and behavior of monsoons is critical for safe sailing in affected regions. Sea breezes. These are local winds that occur due to temperature differences between land and sea. During the day, land heats up faster than the water, causing air to rise over the land and be replaced by cooler air from the sea, creating a sea breeze. At night, the process reverses, leading to a land breeze. Sea breezes can be strong and steady, providing excellent sailing conditions near coastlines. Katabatic winds. These are powerful, cold winds that flow downhill from elevated areas, such as mountains or glaciers. They can be sudden and intense, posing a significant challenge for sailors, especially in areas like the Mediterranean or the Antarctic. Local wind effects. Local geography can significantly influence wind patterns, creating unique challenges and opportunities for sailors. Understanding these local effects is essential for mastering the art of sailing. Funnel effect. When wind is funneled through a narrow gap, such as between mountains or islands, it can accelerate, creating strong gusts. Sailors need to be aware of potential funneling effects, as they can lead to unexpected and hazardous conditions. Wind shadows. Large landmasses, buildings, or other obstacles can block the wind, creating areas of calm or light winds known as wind shadows. Navigating through or around wind shadows requires skill and awareness, as they can significantly impact your boat's speed and course. Thermal winds. In some areas, temperature differences between land and sea can create thermal winds, which are particularly common in coastal regions. These winds are generally predictable and can provide reliable sailing conditions if understood and anticipated. Clouds. The sky's messenger clouds are one of the most visible indicators of weather conditions, and understanding their formation, types, and implications can give sailors valuable insights into what to expect. Basic cloud types and their meanings. Cumulus clouds. These are the puffy, white clouds often seen on fair weather days. They indicate stable air and generally good weather, although they can develop into cumulonimbus clouds under certain conditions, bringing thunderstorms. Stratus clouds. These clouds form in flat, uniform layers and are associated with overcast skies and steady, light precipitation. They indicate stable but often gloomy weather, with little wind. Cirrus clouds. High, wispy clouds made of ice crystals, cirrus clouds, often indicate that a change in the weather is coming, as they can precede warm fronts or storms. Cumulonimbus clouds. These towering clouds are a sign of severe weather, including thunderstorms, heavy rain, and strong winds. They can form rapidly, making it crucial to recognize them early and take appropriate action. Reading the sky. Learning to read the sky is a skill that can take years to master, but even basic knowledge can be invaluable. Pay attention to the types of clouds, their movement, and their development throughout the day. Combine this with your understanding of pressure systems and fronts to build a mental picture of the weather ahead. Morning sky. A red sky in the morning often indicates that a low-pressure system is moving in, bringing bad weather. The old adage, "Red sky in the morning, sailors take warning," is rooted in this observation. Afternoon clouds. Cumulus clouds that build in the afternoon and then dissipate are usually harmless. However, if they continue to grow, especially into cumulonimbus clouds, a thunderstorm could be on the way. Cloud movement. The direction and speed of cloud movement can give you clues about the wind at higher altitudes, which often precedes surface winds. Clouds moving quickly across the sky can signal that strong winds are on the way. Storms. The sailor's greatest challenge. Storms are among the most feared weather phenomena for sailors, and rightly so. They can bring high winds, rough seas, lightning, and rapidly changing conditions. Understanding how to anticipate and respond to storms is critical for survival at sea. Types of storms. Thunderstorms. Often formed by rapidly rising warm air, thunderstorms can bring sudden and severe weather, including strong winds, heavy rain, lightning, and hail. They are typically short-lived but can be extremely dangerous. Tropical storms and hurricanes. These powerful systems form in warm ocean waters and can grow into massive storms with devastating winds and rain. They are the most dangerous weather systems for sailors, capable of producing waves over 50 feet high and winds exceeding 150 miles per hour. Extratropical storms. Common in the mid-latitudes, extratropical storms are associated with low-pressure systems and can bring strong winds, heavy rain, and rough seas. They are often less intense than hurricanes but can still pose significant dangers, especially in higher latitudes. Storm preparation and response. Monitoring weather reports. Before setting sail, always check the weather forecast and monitor it regularly during your journey. Pay special attention to warnings of severe weather and be prepared to change your plans if necessary. Understanding storm tracks. Knowing the typical paths of storms in your region can help you avoid the worst conditions. For example, in the North Atlantic, hurricanes generally move westward before curving north and east. Being aware of these patterns can help you navigate around the storm rather than through it. Heaving to. In extreme conditions, heaving to can be an effective strategy to ride out the storm. This involves setting your sails and rudder in such a way that the boat maintains a steady position with minimal forward movement. It reduces strain on the boat and crew, allowing you to wait out the worst of the weather. Using storm sails. Specialized storm sails, such as a storm jib or trysail, are designed to withstand high winds and can help you maintain control of your boat during a storm. They are smaller and stronger than regular sails, making them more effective in severe conditions. Modern tools and technologies. While traditional knowledge of weather patterns remains essential, modern technology offers powerful tools to help sailors navigate the elements more effectively. Weather forecasting tools. Satellite imagery provides real-time images of weather systems, allowing you to see the development and movement of storms, fronts, and other patterns. Weather apps and websites. Many apps and websites offer detailed marine weather forecasts, including wind speeds, wave heights, and storm warnings. These tools can be invaluable for planning your route and making informed decisions. GRIB files. GRIB, gridded binary, files are a popular way to receive weather data on board. They contain detailed information on wind, pressure, and other variables, and can be used with navigation software to plot your course. Onboard instruments barometers. A barometer measures atmospheric pressure and can provide early warning of changing weather. A sudden drop in pressure often indicates an approaching storm. Anemometers. These devices measure wind speed and direction, giving you real-time data to adjust your sails and course. Radar. Marine radar can help you detect and track weather systems, especially thunderstorms and squalls, giving you time to prepare or alter your course. Conclusion. Mastering the elements sailing is an art that blends skill, intuition, and knowledge of the natural world. Understanding weather patterns is not just about avoiding danger, it's about harnessing the power of the elements to enhance your journey. Whether you're racing across the Atlantic, exploring coastal waters, or enjoying a day on the bay, being attuned to the weather will make you a better, safer, and more confident sailor. As you continue to sail, let the weather guide you, challenge you, and inspire you. The sea is a living, breathing entity, and its moods are written in the wind, waves, and sky. By mastering the elements, you not only improve your sailing skills but also deepen your connection to the ocean and the forces that shape it. Happy sailing!